Dear students, in this video we discuss how the inverter is installed in the house, how the inverter is used to supply the voltage to the different home appliances in the house when there is no power or the power failure. The inverter is installed in the home using the AC main power lines and with other appliances, and its circuit diagram is shown there. It is the power post, the neutral and phase lines from this is given to the main board of the home. Here the phase is passing through the fuse and the neutral is given here, and another earth connection also given to the main board. So from this main board, and this is passing through the meter, power meter, and then the phase line is goes to the inverter circuit or to the inverter. So the phase and the neutral wires are given to the inverter. The inverter consists of the main part, the relay and oscillator and the battery. So this relay operates depending upon the power supplied to it. So these lines again, the phase line and neutral line connected to the home appliances. It is the phase line from the inverter. It is controlled by the relay. So this phase line is given to the switch. Through the switch, from this switch the phase line is goes to the home appliances like the bulb, fan, etc. The neutral line is directly connected to the bulb, home appliances. So we can control the phase using the switch. So the another power line is stepped down and it is converted into DC voltage, and the DC voltage is supplied to the battery. So a 220 volts AC is coming from the street power main post. This 220 volts is given to the inverter circuit. Here the 220 volts AC is stepped down and then it is rectified. It is converted to 12 volt and the 12 volt is given to the battery. 12 volt DC voltage is supplied to the battery to charge. Otherwise, the AC main line directly goes to the home appliances. Already I told you the AC main power line is connected to the inverter circuit, and the phase line and neutral line are connected to different home appliances. So the AC main power line is connected to the inverter circuit, and the phase line and the neutral line is connected to different phase line and neutral line connected to different home appliances. From these 2 points we can connect more home appliances from these 2 parts. It is a phase, it is a neutral. Now it is shown in this diagram. So in this diagram we have taken only the phase line. It is a AC in phase line. It is the inverter circuit. In this inverter circuit, the main part is the relay. The relay allows the main AC in, and there is a common key. If this connect to this pole, the AC main is connected and then it goes to the AC outline and then to the home appliances. if there is no AC power, if there is no AC power, AC main power from the AC main power post, the lever is connected to this pole. So it connected to the inverter circuit and the battery. From the battery, a DC voltage is supplied to inverter circuit. This DC 12 volt DC is again converted into AC 220 volts and it is passing through this AC output. So this inverter circuit consists of the relay which controls the AC in out lines, and this inverter circuit which used to convert AC to DC voltage or DC to AC voltage, and this battery charger circuit, even fed with 220 volt AC. This battery charger circuit converts the high voltage 220 volt AC into low voltage AC and then 12 volt DC voltage. It rectifies. It converts the AC voltage into DC voltage and it is supplied to the battery. So this DC voltage used to charge the battery. It is a simple block diagram about the installation. When the AC main power is present, if the AC main power is present, the relay in the inverter connects directly to the power outline. See here, it is the phase line of AC main power. Now the main power is present. The relay is the electromechanical device. The AC, the main AC line is also connected to some part of the AC voltage is also connected to the relay. The relay consists of the electromagnetic coil. When we pass the current through the electromagnetic coil, it is magnetized, so it attracts this lever, and the lever connects to this pole, this point. So the AC main power goes through these lines. So it goes through the AC outline. This AC outline is directly connected to the home appliances like bulbs, TV, fridge, etc. So the another part of this AC is connected to battery charger circuit. This battery charger circuit of the inverter consists of a step down transformer which converts high voltage AC into low voltage AC. Again, the low voltage AC is rectified. That is, it converts low voltage AC into DC voltage. This DC voltage is given to the battery. So, battery gets charged using this DC voltage. It is the action of this circuit. So, at this same time, the AC power is rectified by the rectifier circuit present in the battery charger circuit. So, the rectified DC voltage is supplied to the lead acid battery. The battery charges using this DC voltage, and this diagram is shown here. This one. Okay. Now, when there is no AC main power, the charged battery, already it was charged. The charged battery supplies a DC voltage to the inverter circuit. This inverter circuit converts the DC voltage into AC voltage. Already we have studied about the process how the inverter converts the DC voltage into AC. The inverter circuit consists of a a stable oscillator using transistors, and a amplifier, and then a step up transformer. So the 12 volt DC voltage is supplied to the oscillator. So a stable oscillator converts the DC voltage into square wave forms. This square wave form is also amplified using the metal oxide semiconductor, field effect transistor, MOSFETs, and this amplified voltage, continuous voltage, is supplied to the primary of the step-up transformer. This step-up transformer converts the low voltage into high AC voltage. High means 220 volts AC with 50 Hz frequency. So the output of the inverter is 220 volts AC with 50 Hz, and it is supplied to this line. So this lever is connected here. So the AC output is goes to different home appliances from the inverter. So the 12 volt DC voltage stored in the battery is now converted into 220 volts AC with 50 Hz. When the power is failed, so this battery supplies the DC voltage, and the DC voltage converted into AC high voltage, and it is supplied to different home appliances. When the AC power is again switched on from the AC main line, the relay again connects to the main line. So this relay, this pole is connected here. So main line. So the AC again passing through this wire. Okay. What are the common faults and find in this inverter circuit, and how they are troubleshooted when there is no AC supply to the electrical instruments? First, we have to check the AC input power, whether the AC input power is supplied to the inverter or not, and then check the inverter mode and relay. Relay plays a vital role here to control the AC and AC power. If there is low voltage from the inverter, then check the DC battery condition and the inverter circuit amplifiers and the power transistors, etc. Measure the low cutoff and high cutoff line voltage, and it ensures that the earth is properly connected or not. And also check the main switch of the UPS. If not, switch on the inverter in the on mode. And regularly check the acid and water level of the batteries. So it is the main troubleshooting process, and the common faults occurs in the battery. So maintaining the battery with proper condition, so its life will be increases.